Thanks, Ali. So now on to our third and final talk of the session. We're going to hear from Monika Szynaka, who's at CCMAR in Portugal, the Center for Marine Science, and she's going to talk to us about some potential improvements on the way in the trammel net fisheries there.
So good afternoon. My name is Monika Szynaka. I'm from CCMAR, as Mark said, in Portugal in the University of Algarve. The project I'll be presenting today is fairly new. The name is trammel or trammel net selectivity in collaboration with IPMA and funded by Schmidt Marine Technology Partners. And my co-authors are my colleague Pedro Rocha, who's here today, Pedro Leitão, Jorge Gonçalves, and Ida Campos. So we have to understand initially the problem, and that is habitat deterioration, specifically in corals and sponges. And we know that these are two organisms that serve as food sources, reproductive areas, and filter water, among other niches. And what happens is that often there is damage that occurs because of gear, either due to strikes, drags, detaching entire colonies. And what we found from previous studies is that there are high catch rates. So 60 to 85% in two different studies, it was observed that there were corals being caught in gillnet hulls. And so ultimately, this is problematic also for the fishers because it creates net damage. So in Portugal, we do catch a variety of invertebrates as discards, including starfish, snails, bivalves, and urchins. But today we're going to be specifically focusing on habitat-forming species such as sponges, hard corals, and soft corals, or gorgonians. So in terms of past work, what we're currently doing and what are the next steps, we have modified the trammel net under that lifts the net 20 centimeters off the bottom within the scope of the project Tech Pescas. We conducted experimental trials and interviews, and then we continued to do interviews recently this year in trammel. And essentially what's happening now is, based on the suggestions made by our fishers, we are having nets constructed, and next thing, when we get back to Portugal, we're going out to the field with them. So to explain a little bit, what is a trammel net? A trammel net is a 3-mesh panel consisting of 2 outer mesh panels that are of large mesh size and 1 inner mesh panel that is of smaller mesh size. And in this project, we're going to be conducting interviews, experimental fishing. 10 of the trips are going to be in the West Coast, 10 of them in the South Coast, with 15 nets that are the standard trammel net and 15 nets that are experimental. We're going to identify individuals to the species when possible. And using GoPros, we will do a comparison of our real-time data compared to what we find in the videos. And finally, importantly, we're going to do a net damage assessment to understand the durability differences between the two types of nets. And ultimately, we're going to take all this information to our fishers in workshops. And the main objective of this project really is to involve the fishers from the beginning in the net development and testing to increase the probability of voluntary adoption of this type of net and maybe in other fisheries, as well as in other regions and maybe gill nets. So in 2022, we presented the experimental trials to the fishers in interviews, with the main takeaway being that we did in fact reduce catch of habitat-forming species by 36% with the modified net. Similar catch rates were existing in target species, and the prices of both net types were within the range that the fishers identified that they usually pay for this type of net. In 2023, we dove deeper. We asked the fishers about their licenses and their operations, the trip characteristics, such as the hauling and the setting speed, and the target species, and the gear characteristics. In other words, trying to identify these métiers. Then we asked about the fishing grounds, so we presented to them these maps, which allowed them to identify where they're fishing, and this is based on us being able to understand the depths at which they are fishing with trammel nets and their respective sediment types. And then we used another form to ask them questions that are more specific to trammel, which is how much are they paying per net now? What is their main bycatch species? Do they catch corals and sponges? Can they identify these species? And if there are other modifications or improvements that can be made to these nets. So we took our previous nets out to sea, and using a remote operated vehicle to understand the net behavior, we found that on the left side you'll see just the lead line actually of the standard net, which is laying flat on the bottom, whereas on the right side you'll see the modified net, and what we found was that it's actually being lifted up by the current, not what we assumed, which is it's being fully lifted up. However, fishers did find a solution for this when we did a workshop with them and showed them these videos, and that is what I'm going to present now, which is the evolution of the net. So we have the standard trammel net, which is on the bottom. You can see the bottom of the net is touching the lead line, and it's touching the bottom of the sea. In 2021, we used this, what they called araña, to lift the net off the bottom by 20 centimeters, and as previously stated, it only lifts up based on the current. So what fishers suggested was actually adding a buoyancy upper cable to the bottom of the net to actively lift the net off the bottom. So now we have some maps, and this was important for us to understand where they're fishing, depths, and what is their main bycatch. So in the south coast, they're fishing in a coastal lagoon called Rio Formosa in the center and east parts of the Algarve, with 100 meters maximum in soft sediment, and basically the majority of their bycatch is starfish, urchins, sponges, and squid eggs. However, they did inform us that they are in fact catching corals and sponges. And the same was said by the fishers on the west coast, where they also fish in the Sado Estuary Natural Reserve at 150 meters depth and various sediment types, and also the bycatch is starfish, urchins, and algae, as well as sponges and corals. So the main takeaway from the results of these interviews was the concern and how can we apply this to the new modifications. So the first concern is flatfish are going to go under the net. So we decided that instead of it being 20 centimeters in height, we're going to make it 15 and close in that gap on that modification part, that diagonal part. In terms of the net damage that occurs with rockier bottoms and therefore costs, we're reducing contact with the bottom. Endurance of the net, we decided to go with changing to a multi-filament net instead of the one that they usually use, which is monofilament. And finally, in terms of sensitive species and vulnerable marine areas, again, we're reducing contact with the bottom. So for the discussion, to talk about a little bit of the price of the new net, we want to reduce the costs of damage and thus buying new nets. And what we found is that the price that we pay for this modified net is actually similar to the range that they're already paying for their standard nets. With 2021, we paid 23 euros difference between the two net types, and in 2023, we're only paying 15. So we're closing in that gap, which means that there's going to be less of an economic deterrence. We want to further reduce the catch rates of habitat-forming species and changing to these multi-filament nets, which are stronger because the fishers themselves will fix these nets because they're so expensive, as opposed to just throwing them away. So they last years compared to the monofilament nets that will last maybe 6 months. And finally, regarding the benefits of the fishers, we want to reduce the time that they're spending at port cleaning the nets. They're there for hours after being hours on the sea, and hopefully, potentially increasing their profit. So for the conclusions, what we found was that the fishers in this last round of interviews said, if it works, we're going to use it, which is great for us. And the objectives of these experimental trials, and something that we weren't able to do previously, was this net damage assessment, as well as mapping fishing efforts in vulnerable marine areas. And in the future, we want to expand to other regions if this works, and expanding to gill nets. I want to thank all of you for listening, and I can give you my email later. We also have an Instagram for this project if you want to track it as we move along. It has the same name and logo as you see on the top left. And yeah, thank you for listening.